I worked at Turner Broadcasting for a long time. Bleacher Report was one of our brands. I spent a lot of time with our entertainment brands as well as some of the sports and CNN. But today, I'm going to talk about what I've been doing for the last year and a half or so, which is building really cool Elixir apps, Phoenix apps, specifically focused on AI and bringing LLMs to bear. I'm trying to answer this question. So, I mean, if you're coming to this talk thinking, let's get way into the details on models and those kind of things, that's not really the point of this talk. The point of this talk is more about, as a lay person or a person, you just keep hearing about AI, but you don't really know where to start. That's what I'm going to try to answer today, or at least give you a couple of pointers. So the objectives are, when you leave here, I'm hoping that you have an understanding of some key AI capabilities. You have an idea how you might want to incorporate AI into some of your apps, and leave you with some additional information. 40 minutes is not going to be enough to go into real detail, but every time I've given this talk, people come away with something that they learn and they want to go learn more about. So this is my disclaimer. If internet time is in dog years, then AI time is dogs using the internet, because everything changes so very quickly with this. So, it's a disclaimer because inevitably somebody is going to say, oh, what about this? Have you heard of this? And it's something I haven't heard of because it's just impossible to keep up. So that's one of the reasons why events like this are so important, is because we get a chance to pretty quickly get up to speed on things that are sort of the cream of the crop. All right, so first I wanted to give a little bit of thought about why AI is blowing up, and it is important to the conversation. So the first easy answer is just because it's cool, right? I'm sure, I mean, some of my aha experiences were the first time I saw image generation, the first time I saw Copilot. There's a lot of things called Copilot now, but GitHub Copilot. And just chatting versus searching when you're trying to learn a new topic, just asking it things and getting information. All those were really aha experiences. But I think the more important reason and the point of the talk today is this, the next couple of slides. So we're talking about building an app, and there's all these foundational layers that happen below it. And the question is, how far down the stack do you want to build, or do you have to build? And if we look at what some of those layers in the stack look like, there's things like hardware, sort of the tooling that goes right on top of that, the data or the models that are on top of that, dev libraries, operations, all of those pieces. And then there's the piece that a lot of us are building at the very top, which is things like websites, video games, mobile apps. I know a lot of people in this room are probably actually working in the layers below, but a lot of people are also working at the top layer, and that's the focus of this talk. So this is not supposed to be an exhaustive list of things that are the foundational layers in AI, but these are a pretty good smattering of things just to give you the idea. Some of the foundational pieces that have been built, and when I overlay the years that these came out, you see that it really gives some picture as to why AI is exploding right now. Because now we can focus just on this part if we want to. If you were starting to build something 5 years ago, this existed, maybe GPT existed, and you had to build all of this. The starting point was going and getting a bunch of PhD, getting a whole bunch of data, creating an ML pipeline, and starting right here. And starting here, it costs millions of dollars. By the way, you can explain lots of things this way. So this is the .com explained. This is the traditional place. If you were saying, I want to go learn AI, you would start someone, this is like week 2 or 3. But I say, not today, linear algebra. All right, so just one more disclaimer. Everything I'm going to show you today is using OpenAI. There's nothing really that special about it. There's a lot of different alternatives. There's reasons that you may not want to use OpenAI, depending on what your needs are around privacy and things like that. But it's a very good way to get started, very easy. And if the goal is play with something today, you could do this today. And also, just as I was building this overnight, 24 hours of usage, I built a whole bunch of images. This was the price tag. I apparently did 500,000 token requests on my embeddings, which we'll talk about next. That cost 5 cents. So it's a pretty cost-effective way to get your hands dirty, play with some things, get some understanding. All right, so now let's get to the good stuff. All right, things that we're going to talk about today, embeddings, generating text, generating images. You guys heard of RAG before? You guys built RAG things before? Okay, no? Okay, awesome. That's good. I mean, if you haven't heard of this stuff, that's your right audience, because that's who I want to reach. And we're going to talk a little bit about AI agents. We'll see some of this working as well. All right. I wanted to make this a little bit interesting, not build a blog or something very simple and or boring, I should say. And so instead, I built a game, and it's called Questify. And it is pretty simple. It's designed to be hopefully grokkable. The idea is a choose-your-own-adventure style game. Do you guys remember Choose Your Own Adventure? Awesome. And by the way, the UI for this, I'm not a CSS guy. I just put an image of Bard's Tale into ChatGPT and said, give me some CSS that looks like this, and it was pretty awesome. So let me show you. So the idea is you're going to move from location to location. So in the book, if you don't recall, is you would open up the book on page 1 and say, you're walking down a path and you go left into the castle, or you go, jump in the river or something like that. If you want to go in the castle, go to page 52. If you want to go in the river, go to page 12. And you jump around in the book, so it was a non-linear experience going through the book. Didn't really have a ton of options, though. So I built the non-AI version first. Oh, let me walk through a little bit more of the game dynamics. So this is the nice thing. It's pretty simple. You have a start location, a bunch of other locations you can go to, and then you have this action object that'll take you from location to location. From a data model perspective, it looks like this to start with. There's some more to it, but just so you kind of understand as I'm jumping through some code. One thing I think I forgot to mention is here. All the code is out in GitHub. I released it all. So what I'm going to show you is just going to be snippets that are important for the concepts as much as I could. But a lot of these things they're actually like 7 steps. So go in there if you want to dig really into the code. But I should give you enough to understand it here. And you can go play the game too. All right, so let me give you a demo of it real quick on the non-AI version. So this is what it looks like. I'm going to go in. I have different quests that I can do. I'm going to do this Hello World one. Gives you a description and image of the quest, and I decide to play it. And this is very similar to the book, where it would say, here's a description. What do you want to do? Do you want to, let's investigate the room. So I'm going to hit 2. It's going to give me some information and basically bring me back to the same location. And I'm going to say, let's go to the backyard and see what happens. Yay, I win the game. Let's see what happens if we go the other direction. Uh-oh. I'm gonna go do a 3 here. Take those stairs. Oh no. Ran into a Balrog. Okay, well, happens. All right, so that's the non-AI version. And what I want to do is layer in some capabilities so you can see how things can improve. This is the admin page you're probably familiar with. And the way I generated this and some of the others was literally went to ChatGPT, said, make up a story, give me some names of places, copy them all, put them in here. So it was a very manual process. So, any questions so far? Okay. All right. Not there. All right, so the first sort of foundational capability, and I probably overuse this capability because it's really, really powerful, is called embeddings. And embeddings look pretty simple on paper. So what they do is you have some string, doesn't really matter what it is, you put it through an embedding function, and for this I'm hitting a API, and I get back a whole bunch of numbers, 1,500 of them. These numbers have meaning to them, so if I embed 2 similar pieces of text, they will come back similar, and I'll show you how that works. But the intuitive thing that I like to tell people is if you take a king, the word king, embed it, you take the word woman, embed it, and you add those 2 together, the result of adding those 2 vectors together will be very similar to if you just embedded queen. So the numbers actually make sense. So let me show you it in action, and then we'll walk through the code. All right, so this is the more AI version. You'll notice that the numbers are missing. So what that means is I can say things like, well, let's investigate the desk. And the cool thing is I don't have to spell particularly well. It'll tell me this. Oh, and this one I added a continue button. The other thing that's cool about this technique, or using it here, is I can add hidden things. Like instead of having everything written out that what you can do, you can have other things to do. So it can be a lot more of a experience where the person is exploring versus everything just being there for you. So that is one. I'll show you more examples, but that's sort of the simple example. Let me walk you through some of the code. So here's the API. This is the OpenAI. Oops, let me do it this way. This one, not too much to it. This, even though it seems simple, there is, I think, literally 7 steps. So I wrote an article on what those 7 steps are, how to do them. So if you want to take a look at that. But what I'm doing is, there's another, I'm using, have you guys heard of a vector database? Does that make, so you have to be able to store these vectors and search on them. And that's not supported out of the box. So there are things like ChromaDB and other databases that you can get off the shelf that do this. But I prefer to use just an extension PG vector to Postgres. That way I don't have to change my operational setup. I can just add an extension, and now I can do things like combine other parts of my where clause. So the action that I had before, now I'm going to have one additional field called an embedding. And user doesn't, you don't have to do anything with that. What I'm going to do is every time someone does a create, I'm going to go hit, this is basically going to go hit that API for me, pass in the command value, which is investigate the desk, and get back this embedding. I'm going to add that to my map, and then I'll just store that. So kind kind of behind the scenes, the user doesn't have to think about it. And then here's the cool thing. Now, when somebody says, here's an action, or I typed in something, the other ones were the actions that are stored on the game, right? Like the available actions. This one is the list, is what someone is typing in. So they're at a location, they're going to type something in. I'm going to embed whatever they type in as well. And then I can do this cosine distance to determine how closely related whatever they typed in is to all of the different available options. So this is where I was saying, I can also combine cosine distance with other elements of traditional database queries. And then I'm just simply ordering by the distance and getting the first one. So that's going to help me pick whatever is most closely related to whatever they typed. You can apply a distance to one is essentially going to say, give me everything or anything, but later on I'll do a little bit more restrictive of one. That's how embeddings work. Any questions on that? Cool. And by the way, happy to talk after this too. I know it's a little bit of a quick pace, so I'll be outside. But if any terms are confusing, I would like for people to ask that because I don't want to just keep going and people be confused. Yep. That is a good question. I haven't, does anyone know the answer to that? Can you do embeddings in other languages? Depends on the model, okay. Yeah. All right, so let's talk text generation. The intuition on this seems pretty obvious. You're going to ask something. This is similar to how you do your prompting generally. Let me show you where I'm using this. So I mentioned before I can put in sort of hidden, get rid of this. I can put in hidden actions. So now there's one here where I can say, tell me about, I could say the waterfall. And it goes, it's just making up stuff right now, it's not real. I do think that this game kind of could be cool to have it where you're exploring and things are actually related to each other. But I mean, this is somewhat related because I'm feeding it, I guess I'll show you. I'm feeding it information about the quest that you're on. But it's not really that relevant to the game. So I'm hitting this API. There's an additional parameter available here that I'm using that is stream true or false. So by default, it's false, and it's a lot easier. You just hit it and you get a blob back. But you'll notice a little, maybe one or 2 seconds while it's generating, depending on which model you use as well. But you can pass in stream true, and you'll get information as it's being generated. And I'll show you how I did that too. All right, so this, when people talk about prompt engineering, that's what this is here, where I'm sort of constructing all of this stuff. This is where I'm saying I'm passing in the quest name, I'm passing in the description. That way the person knows that they're in a pirate adventure or they're in a Dungeons & Dragons type adventure. And then I'm passing in the actual request, and I'm getting back an unstructured set of text. This part's not that interesting. I'm just hitting an API, hitting a post. There's additional options. I said there's streaming. You can also do function calling where you tell it to give you back something in the structure of a function, and then it's up to you to run that. I'll show you some variations of that if we get time. Streaming was a little bit more difficult, to be honest with you, but look at the project and you can figure it out probably more quickly than I did. But I'm using HTTP Poison. I've seen it also obviously in request, but you start a stream, you're receiving as chunks are coming. This is a whole bunch of junk where I'm just parsing it out and getting the pieces I want. But it's giving me JSON objects that have literally like a token at a time sometimes. So you have to do a lot of updates. But this is an area where Elixir and Erlang are so awesome, right? Because as I get every text update, I can just broadcast it. And you saw how quickly it was happening on my page. I didn't have to do anything, right? I just said, as a chunk came, broadcast, broadcast, broadcast. And then, yeah, over here, when I get the text update, I'm just appending it to whatever that text box is. Make sense? Awesome. All right, image generation. This one, I'll show you. Sure, I'll show you. I'll follow the slides, fine. On this one, I should be able to just say the attic, I think. And it's going to go build this. I'm not sure if it'll live update or not, but it'll go build that. We'll see a more, oh, there it goes. So that's also, it's using the same techniques. Essentially, you saw how long it takes. It's not something that you would want to put in process, so I'm handing it off to a gen server, so it's going and doing the request for me. I'm using that same hash technique where I'm passing along a key so that when it comes back, I know to expect it, and doing that broadcast. So I'll show you some of those things. Be conscious of time. I know I want to show you some of the cooler, I'm building up to the cooler stuff too, I hope. All right, so yeah, this is, I mean, these images are just so cool. I mean, the fact that they just pop out and they cost 4 cents. Here's an example of the API call. By the way, this is just literally cut and paste from the OpenAI documentation. So it's very clean. I actually think it's pretty solid. Unfortunately, they give you curl, Python, and JavaScript, so you have to figure out the rest. So what I'm doing here now, and you saw that, is I'm creating a location. After this insert is successful, now I'm going to go and do a, this is my gen server. I'm going to pass it this prompt. Generate an image portraying the scene, and I'm passing the description of the scene and say, go do that. And I'll handle it when it comes back. Okay, and this is what happens inside the gen server. There's a couple different ways to do it. There's a lot of different parameters you can give. What I'm doing is I'm getting back the URL. You can request just to get the whole image object back too. But I'm getting the image URL, downloading it, I'm writing it to S3, and then I'm doing that broadcast so whoever is waiting for it knows that it happened. By the way, one of the things that they don't give you from an image creation is a seed. So you can't create the same image again the way you could with Stable Diffusion or something else. The reason they do that, I'm pretty sure, although no one's confirmed it, is they don't actually prompt a white Siamese cat. One of the things that people were doing 6 months ago or a year ago in order to get better image generation was they would take something like a white Siamese cat, they would give it to ChatGPT and say, hey, what would be a good prompt for this string? And it would give you a really big, hey, a cat's sitting on a couch and looking this way, and it would give you a better prompt for an image. So they're doing that themselves. When you give them something like this, they translate it into a better prompt for you. That's one reason it looks so good. All right, but that's one, aside from just saving costs and those kind of things, that's one reason I'm storing it on S3 and not trying to generate it in real time. It's also faster. All right, so this is now we're getting to the really cool stuff. Structured text. Structured text is in the same vein. It's not a different API, but there are different libraries. And the intuition is, instead of, the first time I tried this, I would say literally, hey, give me a CSV that looks like this or a JSON that looks like this, and I'd parse it out. And sometimes it gave you valid responses, sometimes it didn't. And sometimes it wasn't actually what you were asking for. But now what you can do is you can say, here's a schema. I want a name, a description, maybe a Boolean. You send it over to this library, and then you get back an actual object. This probably should have a % over here, because that's what it'll return. So this is an example of that. I was playing with the idea of that rumor thing earlier. So you literally define an ecto schema, and you hand that off, and you say, I'm using this library that's amazing called Instructor, and there's a version of this in Python as well that's based off of, but I found this is really solid already. You give it this, you give it something like this that's amazing. It says how many times I want to retry it. I don't have to worry about it anymore, where if it fails to parse, it'll do it for me. But the really cool thing is it's going to use ecto under the hood. So you give it something like this as part of your definition of your schema. And you say, okay, I want the name to be in these parameters. And if it fails, just like you would with a human, where you would give them a response on the input page to say, wait, your name has to be, or your password has to be this, it's going to give the text response, because LLMs understand human language, back to the LLM to say, let's try that again. Here, give me it with this validation. It's freaking smart, right? So I sort of jumped over, but check this out. Definitely, if you're playing with this, this is probably more powerful than hitting the text itself. I would probably wrap everything in something along this line, just to be able to get the validation and the retries. It also handles streaming of JSON. So it's streaming back tokens that are invalid JSON, and it's handling it to the best of its ability. It's pretty impressive stuff. Let's see. I'm going to use it in a second, so then I'll show it to you. All right, now we will get to RAG. So RAG stands for Retrieval Augmented Generation. The thing with LLMs is they're not very, they're smart, but they, I use the analogy of like a college graduate that has amnesia. So they know a lot, but they don't actually learn anything new until you retrain it. So that's why when you ask ChatGPT, it'll say, well, I don't know anything since March, whatever. So what you have to do, there's two techniques really, maybe there's more, depending on how quickly AI time is passing. But the main two are either RAG or fine-tuning. And there's different reasons that you may want to use some of them. But what RAG is like doing in this college person analogy is you're going to ask them a question like, maybe I have it. You're going to ask them a question, you're going to give them some information. So here's the very high level. You have some prompt, you're going to have some augmentation function that's part of the app that's going to add some knowledge, feed that with the prompt to the LLM. What that might look like in practice is something like, let's say you're building an app that is an intranet site for a company, and you want to know something like, what is the company policy on time off? That's probably not a thing that you would want to fine tune, because it's probably going to change too much or it'd be too specific to that use case. So what you do is you go get information from the company website, just feed it a bunch of pages that may or may not be relevant, hand that with the prompt, and then the LLM could probably read through, I mean, it could read through dozens of pages and figure out if it's relevant or not to the question that you're asking. And yes, it uses the embedding idea to figure out what's potentially valuable. So there's really two phases here. There's this phase, the pre-processing phase, where you would want to do something like ingest your documents and put them into a data store. So ahead of time, you go take your information, you chunk it, we'll talk about that, you embed it, stick it in a database. So then when you have a real-time prompt come in, your augmentation function will go hit the database and say, give me something relevant to whatever they just asked, and I'm going to feed that. All right, so chunking is just a way to say you're not going to, I guess I haven't talked at all about context windows, but LLMs, I think you can only hand it so many tokens or so much input, right? So you have to be a little bit conscious of it. So the intuition of chunking is if I was going to feed it a book, you may say break up every page, turn that into what I'm calling a body, here, and then I'm creating a chunk with each body and then the theme that it's related to. So I'm taking that through, storing that. I'm using this, I was trying to make the quest thing where you have different themes, so like a Cthulhu theme, a cyberpunk theme, a pirate theme, and I went and found books off of Gutenberg, and I ingested them through this. Let's skip through this a little bit. Again, using using Instructor to do image generation, and I'm feeding it now the RAG text based on the name of whatever you're calling it. I'm going to go try to find relevant pieces of information from this book. All right, I'm almost there. All right, so the intuitional agents, and this is where superpower, this is really like a responsibility thing, is that an LLM, you can say, hey, write me some code that does blah, and it'll give it to you. An agentic approach is, hey, write me some code that does this, and then execute it. So it could be scary, but it's pretty impressive when you see it working. I built things that integrate that are like, hey, create a new Jira ticket, and it puts a ticket in Jira through a chat. It's pretty cool running in Phoenix. All right, let me show you this. We're getting close, and then maybe I'll open it up for a question as well. So the idea I had with all of this power was, what if I made a game, it's a choose your own adventure game. And it doesn't have that much to it. But I could say, let's go to the library. And in real time, honestly, I think DALL-E is a little bit slower today, but real time, as you're saying, let's go here, you're exploring and you're creating a world. And other people, I'm not just creating a world in the same sense of what I was doing before where I'm showing you text. I'm actually creating more of the game by exploring it. So if other people are playing, we could all be sort of creating a world and exploring a world together. So that's an example of, I think, an agentic thing where as you're interacting with text, you're actually creating and changing things around you. So that's all I have for today. So did you want to do questions? Yeah. Yeah. I think we have time for a question or two. Put up.
For the RAG example, I'm curious like what the practical limitations are on like the size of text you could use. You do mention uploading stuff from Gutenberg. That seems like pretty large text.
That's why you do the chunking up front.
Okay.
So and what I was doing was pulling out 30 lines. I was just doing a pretty naive approach of literally 30 lines, but there's semantic chunking as well where it tries to break it on pages or paragraphs. But that is one of those things that they talk about, like hyperparameters, or maybe you would call it just prompt engineering. Like, do I get better results with 3 or 5? And sometimes giving it too much can make it confused too. So I might want to have less chunks that are more relevant.
Gotcha.
One, and then you.
It's interesting to me to think about the idea of kind of like mixing the generation with kind of a more cohesive storyline. So I'm just kind of curious, like, how would you go about that? Would that information about the cohesive storyline always have to be embedded in the prompt, or do you think maybe there's some like application tricks you can do, like even like run what's going through the LLM and have the LLM tell you like, is this player getting too far off like the track, and kind of like shoot them back to where you want them to go?
Yeah, no, that when I showed that one example, I was kind of going down a rabbit hole of that. Instead of just saying make up something, it was make up something about specific locations that already exist. So kind of feeding information that's in the game back into the prompt, as you're saying. I think that's probably the way to do it.
How are you selecting which chunk to send along to the LLM?
Right, that's using the same technique as the embedding cosine distance. So what I'm doing is looking at, in this case, it's for some of those books, it was like 1,000 chunks and doing cosine distance, so it had a lot to pull from. And I think I was using 5.
How well does the embedding approach work with modifiers? Like if I have some fragment like show me all dogs and I change it to show me all not dogs, like does that tend to actually behave properly when embedded, or do I tend to still have weird clustering issues?
That's a great question. I don't think I've tried that use case. Yeah, I would think that it would understand that, but I mean, there's also the 2-phase approach where you're grabbing chunks that are cosine similar and then you're giving it to LLM, and then the LLM would be potentially smart enough to pull out things that don't make sense too.
Awesome. I think, yeah, that's all for questions. And thank you so much, Byron.
Thank you.